Hi, welcome to Data Engineering, and today we are going to discuss about big data project. So one of the big data project that I have done in my previous experience, I'm going to explain you the architecture and like audience for this video, right? So if you are a fresher, if you are a recent college graduate, you can still able to see the video, and you have some experience in industry. Like I have been in industry for 3 to 4 years, and now I'm into big data. I'm very newbie to the big data. Yeah, even for you, this video will be suitable. And if you say like I'm more than 10 plus years of experience. Can I still watch this video? Yes, you can also watch this video. And fourth audience, like you've been already in big data for some years, but still you are struggling to articulate your project in the interview. Even for you, this video will be very helpful. And people who already working in some data technology, few things which I'm going to explain in this video will be more familiar for you, but still don't skip the video. I will recommend you to watch the video till end. Yes, we can jump into the topic. So here it's going to be the data migration and data transformation project. So my source, I just wanted to tell you my source. It's a DB2 database. It's an RDBMS. So here as a data engineer, I used to get the requirement from the client, right? Client or a BSA, right? We used to get the requirement. So here is the requirement. It's a banking domain. Just imagine it's a banking domain. And the client is asking you a report. The report should have in last month how many credit cards that we have offered for customers, and in that for how many credit card users we have announced offer, and again out of that offered customers how many of them they have used the offer to purchase what product. So this is what they're asking. So they need to know how many credit cards has been offered for the customer in the last month, and how many have been announced an offer for their credit card, and how many of them have used the offer to purchase what product. So this is what the client is asking me, and this report has to be get scheduled on monthly basis for every month before fifth date, right? We have to hand it over to the client. So this will be like an automated process. It has to be get scheduled. I will tell you those part all scheduler part as well. I will tell you. So now you have to identify the source table, because the report what client is asking, this data will not be get stored in one single table. Am I right? So it won't be in one single table. If you see here, so we have so many tables in source. Like if you again go with the requirement, I will just go with the requirement again. So client need a list of customers who have been issued credit card. That means customer information and credit card information, there is two tables. And then how many of credit card user have been given an offer, that means there is an offer table. And how many of them used it to purchase what product, now product table. So there is four tables that I have to get from the source, and I have to do all the joins and blah blah stuff, and then I have to give the report, right? So first you have to identify the list of source table that you need to query. Okay, so now the data is in db2, and I'm not going to do any transformation on top of db2. So instead what I'm going to do is I'm going to bring those four tables data for the past 1 month. Okay, I'm going to migrate. So the component what I'm going to use to retrieve the data from database is Sqoop. Sqoop act as a data pipeline tool to bring the data from RDBMS to Hadoop, Hadoop to RDBMS, right? By the time you might have been heard about this tool, and you might have been worked in this tool as well. So here in the project, what we have done, we used Sqoop, and we just bought the data and we stored it in Hive. Okay, so this is how initially the project started. So we just stored the data in Hive. So again in Hive, like you can directly do after the storage, you just completed the storage part. You just queried the last month of these four tables, and you created a table in Hive, and you have stored it. Now, so on top of this Hive table, I have to do the ETL, that is transformation, extract, transform, and load. So the transformation is nothing, it's just the joins, subqueries, filters, and those stuff, right? So we directly queried Hive, and we have started giving the report to the client. So this is how it started. So roughly like the time of 2015, and in the end of 2015 and in the mid of 2016, till that time people they heavily used Hive. Without Hive you can't see any big data project, and even now without Hive you can't see any big data project. That's why Hive is very important. So by the time when even Hive is part of big data component, but Hive supports SQL, even a lot of SQL developers without knowing what is Hadoop and Hive, they started working on Hive because it's again SQL. But later what happened at end of 2016, as I told you, end of 2015 to mid of 2016, by the time people started getting into Spark. Spark was there even before that actually. So it was even before 2013 actually. But the thing is, people started using Spark with Hive by the time of 2016 mid. People started using a lot. So what happened? So initially people started doing all the transformation with Hive and they generated the report. Now I'm not going to do the ETL in Hive. So I'm just going to use Hive just for storing and just for querying purpose to see the data. That's it. So I'm going to do the transformation with Spark. So we introduced Spark into picture. So you can explain it this way. So you can say that if you say that you have 2 years of experience in big data, you can say initially the project what you have done is we started Hive only for transformations. And then later we started a POC to introduce Spark into picture, and then the POC has turned into project. So this is how you can explain, right? Step by step, only the project will get mutated, right? So you can say initially you have started with Hive and then you introduced Spark into picture. Okay, right. So in Spark, like we have Spark Batch and Spark SQL. Okay. So here initially in Spark, when we decided to do the ETL, the transformations, we started with RDD and then we moved on to data frames. In Spark SQL we have data frames and data set, which is very good compared to RDD with respect to performance. So how Spark is very good with respect to performance compared to Hive, in the same way within Spark compared to RDD, data frames and data sets are more performance. It has more performance. So we started doing all this, and the transformation is completed and you are reading data from Hive. Okay, you are reading the table from Hive, not from DB2. Very important, you are reading the data from Hive and then you started doing all the transformation. So okay, here is the question. You can ask me why Hive. I can, if we are not going to use Hive, then directly we can query DB2 itself, right? Yes, Spark supports it. Still you can connect directly and you can read whatever the tables you want. The thing is, like DB2 is not free. So the connections that you create with DB2, it costs for it. Okay, that is one thing. And whenever you go with the doing transformation within big data family, right, it will be very faster, and that's the reason we first bring the data to a storage and then we are doing the transformation. But I've seen some use cases where people directly query RDBMS. Yes, that is also supported for some reasons. Maybe in upcoming video series I will explain you that, but now we are not using the straight way of doing it. Okay, I will just remove this one. So it's like you are reading from Hive and you are doing all the transformation, and finally we are giving the report to the downstream. So downstream can be a non-technical team or they could be a technical team. So imagine if this is a non-technical team, then I'm giving the report as a file to the bankers, to directly to the bank employees, right? I can give they are non-technical, they just need of my file which I have the report. That's it. Imagine if they are a technical team, that is there is another development team to which I'm giving this report. So what that team will do? So in my case, we handed this report to another technical team. It's again they are also an data engineering team only, but they use visualization to project the report. So we are not taking care of any visualization. So what we did is we generated the report, a Spark output. So this report. So what we have done. Okay, so we just this report we stored it in a Hive table. That means the target table is Hive again. So that means the source is Hive for Spark. Yes. So there here we have a database called source where we store all the source table, and in the same Hive we will create a database called target, and within the under target database we store all these report as a tables. So monthly wise this Hive table will be get loaded, because that is what the requirement from the customer, right? If they ask for weekly, imagine for every month 5th they need the report. So every month on or before 5th the data will be loaded to Hive, or they are asking weekly, then weekly this Hive table will be get loaded. Okay, depends on what's frequency they want the transformation and data to be get populated. So now this report we have stored it in the Hive. So this Hive table, the target table, is what we will be giving to the downstream. So this downstream again they use a visualization technology called MicroStrategy. So they use this MicroStrategy to project to the customer in the some chart format. Okay, so they read the target table from here. Okay, they are not going to do any kind of transformation. They used to design the charts and MicroStrategy. So we as a data engineer team, we used to do all the transformations. Okay, fine. So here As I told you, the Hive part, like the table which get loaded based on the frequency what you say. Now, how come this happens? How we will deploy this project? Okay, I will tell you that. So if it is Hive, right, then it's fine. Just directly SQL file, you can place it in the production, and you can call this SQL file by writing a shell script or Python script. We need some invocation script, right? And okay, you imagine you are writing it in a shell script. So within shell script you invoke this SQL file, and this shell script file is what you have to, the shell script and this SQL file, you have to place it in your cluster somewhere. That's it. So here we are using Spark, right? So if you are using PySpark, then it will be the .py file, or it is Scala or Java. If you use, then it is going to be a jar file. So you have to call this jar file within this. See, if you are using .sql, then in the shell script you have to call .sql. So now we are not going to use this. So we are going to invoke jar file, and this jar file will do all the Spark transformation. So in the shell script, I will write a Spark command to invoke this jar and start execution. So here, this shell script, you have to place it in your cluster somewhere with this jar file. Okay. So now we have to use scheduler. The reason why we need scheduler is client needs this job to run for every month once, right? Or every weekly once. Then we need a scheduler to do this. I can't do manually, right? So some famous scheduler. Okay, I will tell you what scheduler that I have used, Autosys. And similar to this, you have something called active batch and control M, etc. Control M, airflow, etc. So I used Autosys. So in Autosys, so all these schedulers are a different team. You don't want to worry about what is these tools, or you just need to know, okay, they are schedulers. That's it. So even in the interviewer, none of the data engineer will ask you like, how about Control M, or how about Autosys, what internally so on so stuff will do. No one will ask you. And even if they ask you this, you can simply say scheduler has been taken care by a different team. So here, that is the reality actually. So this Autosys team will ask you some informations like where you are going to place the shell script, and where you are going to place the jar file, and in what frequency we need to invoke this. So all this information they will ask you. You have to hand over all those information like script path, jar path, and then the frequency information and so on. So they will give you some Excel sheet, or some online form will be there. You have to fill it, and it goes with an approval, so on so stuff, and then it will get approved, and scheduler will get start. So what this Autosys will do, right? It will invoke the shell script which you have placed in your cluster. So this shell script will invoke the jar file which you have placed in the cluster, and this jar file will start your Spark execution, and the movie starts. Okay. So all the transformation get completes, and then the report will be get stored in the Hive table once the job get complete. So all these schedulers will have some sort of UI or log where you can find whether the job has been completed or not. So with that, you can just query your target table to see select count star from. That's it, right? So you can see whether the data has been populated for this month, and if it is done, you can inform to the downstream, and then the downstream will query it, and they will do use some kind of a visualization tool, or it could be a file that they use some different technology to do whatever transformation they want, or there could be another data engineering team. I'm giving the report to them. On top of that report, they are going to do some transformation. Okay, it's depends on the downstream. So it's always good to say that you are giving to someone who is taken means it's always like you can tell that your downstream is a visualization team, because that's where the picture ends, like, okay. So if you say that you are giving this report to another data engineering team, then they will ask you like what that team will do. Okay, so again we need to know what transformation that they are doing. It depends again, it's there, like the cases are there, but it's to make it so simple, tell them that your downstream is a visualization team in which you will give the report as a Hive table, and they will do all the transformation, sorry, not transformation, all the visualization stuff, the stuff with the Tableau or MicroStrategies, blah stuff. So in my case we used MicroStrategy. Okay, and here comes the information like there will be three cluster environments you will have. First, you will initially develop all your Spark code things, everything in your local laptop, in your office laptop, right? And then you have to move the jar file and script to dev environment. So dev, this environment is again a cluster, 20 node cluster or 10 node cluster. You can say up to 30 node cluster. Dev will be always very small. And then once development is completed, we will move this jar file and shell script to UAT, user acceptance environment. It's a test environment. So in develop itself, in the develop environment itself, we do all the testing too, but still there will be another testing environment. So you have to run successfully on these two. Again, in this cluster, you will have Hive Spark and so on so stuff. Again, you will have Hive Spark and UAT as well. Datas will be different. They are like mock datas. The input datas what you will have will be dummy datas, and production is where you will have the real data. And then you have to move the shell script and jar file to the production, and this scheduler team will take care of doing scheduling in all these three environments. Just you want to tell which environment the scheduler has to run. If you say all the three environment, then they will take care of all the three. So when it goes to production, you have to get the solid approvals and clearance, like you have to prove that your code is good and your input is good and your output is as expected. Okay, so again, these three environment will, the cluster configurations will be different. So you can say like 20 plus node in dev and 20 plus node in UAT. And if you say like, always try to say more than 50 plus node in the production environment. But I have a separate video for cluster configuration and dev production, so there will be a separate video. So you can find that in the description box of this video. If the video is not there, please do wait, I will upload soon. And here, and one more, the last point I want to tell you is, so if some issue that downstream identifies, for example, they are just query this target table and they find there is a null value, and downstream is very sure that this particular table and the particular row should not be null. They are very clear about it. They said there is no possible of having null values, and that means there is a problem with the code. You have to check. And if you see there is no problem with the code, then you have to check the source in Hive, right? So this is the first source, right? And this first source you have used Sqoop to bring it to Hive, right? So here you have to check in the source itself. If you see null, then you can tell them that in the source itself it is null. Okay, now downstream is telling another point, in the source also it should not be null, and that means you have to check the db2 directly. So you can ask me like, the db2 data is what we migrated here, right? If here it is null, then in the source also obviously it will be null, right? So no, it won't be in the case, because like when we migrated it, sometimes in between some problems can happen. Maybe in the Sqoop, when I do migration, some problems might have occurred, right? So we don't know. So if you see null here and still like your downstream or someone from the team saying that the source should not be null, I doubt it. So that means you directly check the DB2 tables. You have all the information to query the table, right? If you have the access to query the DB2 directly, you can do, or you can send an email to the concerned source team to check whether that particular row is null or it has the data in the actual source itself. In the actual source itself, it is null, and there is no problem in your migration. The problem is with this. You have to inform to the downstream saying that in the actual source itself it is null, and there is no issue with my code or in the my migrated data. Okay, then downstream has to check with their own team, like why it happens, all those stuff. But thing is, if db2 has a good correct data, there is no null, but in our Hive there is a null in the source, means when you have done the migration, something you have missed. Okay, so why I'm telling this, right? And high level of some issues what we will what we will face after we load the target table, after all the transformation is completed, this kind of issues will come. Okay, so not only null issues, they will say the value is wrong, the output is not expected. So that case, you have to check your source. Immediate source is your Hive and the actual source is your db2. Okay, so that is what I want to tell you in a high level of thing. Okay, so as I told you already, there is a video called top 10 things that you should know, top 10 points that you should know before and after a project. So there is a video in this title. Please, I recommend 100%, I want you to watch that video first and then this video. If you haven't watched that video, please, the link is there in the description box of this video. Please do watch it, because that video will help you a lot to articulate your project. That's very important. In every video project series video, I'm going to upload a lot of project use cases in my upcoming video series, and all for all those videos, the top 10 points before and after project is very important. Okay, so that I cannot repeat in every video, right? So that's why I have made it as a separate video. So that link is there in the description box. Please do watch that video and then this video. Okay, and if you merge these two videos content, you will get a clear idea of how to articulate the project. And you might have think that whatever the tech stack that I have used is here is like very common, and you think the project is very simple, but this is the reality. So the 80% of any project, big data project you go, they use Hive, Spark and Spark SQL. That is what 80% of project you will see. So this Kafka part, Spark streaming, and then NoSQL database, it's there, but only less projects are using it. But still, I'm going to include those components also in my upcoming video as a project, different project architecture with those component also. But if you are very new to this industry, you are a newcomer, you are a newbie, then this video is completely enough for you to enter into the big data environment to get a big data opportunity. And all the best, and thanks for watching. If you really like this video, please do subscribe channel and forward this to your friends and share this in your LinkedIn, please. That's my request, and thanks for watching.